So here's a quick video as a refresher for 6.5 where we are actually solving logarithms. So make sure that you know all the properties from 6.3. I have just pulled out a few of the main ones. By no means is this all of them. So you'll see up top, if you just remember that e and natural log undo each other, log base something and that exponent undo each other. So for example, log base 2 of x and 2 to the x undo each other. Log base 3 of x and 3 to the x. As long as these two numbers match, they will cancel each other out. Also, your product and quotient rule, if you have two logs being subtracted, you're going to put them into division, and if you have two logs being added, you are going to condense them down to multiplication. So there's just a few of them, but again, you need to know all the properties from 6.3. So here's our first example. This is 18-ish. I changed it around to make it match your homework questions without doing the same ones from the notes so that you would have an additional example. So if the exponents cannot match, so for instance, the base here, 3 and 7, there is no way that I can rewrite 3 and I can rewrite 7 to match. They're both prime. I can't rewrite them anyway. So if rewriting is not an option, then I'm going to go straight to logging both sides. Now remember we talked that you can either log or natural log. I always log. So I'm going to log the left, log the right. Now if you remember, we had a power property that said if you have an exponent, you can bring it down in front. So I can bring down the x minus 4. And then I can also bring down the 2x. Now I'm going to distribute the log on the left because I have a product, an x plus 4 times log 3. And I need to get all the x's by themselves, so I'm going to take this log and distribute it to both of them. So I'll have x and then times the log 3 and then minus 4 times log 3. So I took the log 3 and I distributed it backwards essentially. Now on the other side, that one's all right. I don't need to distribute because it's just 2x. Now I'm going to do several steps kind of in one. I want to take this thing, minus 4 log 3. I want to move it over here to the right, and I want to take this thing, 2x log 7, and I want to move it over here to the left. And the reason is I want all the x's on the left and all the not x's on the right. So I'm going to just do that in one big motion. So I'm moving the 4 log 3 over to the right. So I added it to both sides because it was being subtracted. So now those cancel. And then I'm also going to move this 2x log 7 over to the other side. So it's positive. So the way you undo 2x log 7, I'm going to subtract 2x log 7 from both sides, which will make those two cancel. And so I'll be left with this thing. X log 3 minus 2x log 7 equals 4 log 3. So you may want to take that in two different steps. I just did it all in one to save space. But now I have all my x terms, an x and an x on the left, and all of my terms that don't include an x on the right. So now that both of these terms have an x in them, I'm going to factor out or take out a greatest common factor of x. So now I have x times log 3 minus 2 log 7 equals 4 log 3. Now I still want x by myself, so I have x times something. So to undo the times something, I'm going to divide every single thing by that big giant product. And I'm going to do it on both sides. which will leave me, those cancel. So my final answer will be x equals 4 log 3 all over log 3 minus 2 log 7. So there's my exact answer, which I didn't specify, but this is part A. Part A asks for the exact answer. Part B then asks for you to approximate the answer. So I went ahead and put this whole thing in the calculator. When you're typing this thing in, make sure that you put the numerator in a set of parentheses, which I've drawn in red on the calculator screen on the left part of the screen, and your denominator in one big parenthesis. So you'll see I drew those in blue, which on the right hand side I drew them in blue as well. I just shaded over them in blue so that you could see. Make sure you put the numerator and denominator in separate parentheses so that your calculator knows that whole thing is on the bottom. And then I got out negative 1.573. Again, it said to the nearest thousandths, which would be 3 decimal places. Okay, so here's example 2. It's number 36 out of your book. ln of 2x equals 5. So anytime I see ln, already there's one log, either natural log or regular log. If there's already one, you go straight to the inverse operation. So the inverse operation of natural log is e. So I'm going to e both sides, which just means raise those things to the power, or e to that power. So e and natural log cancel out, which means my 2x will fall down. And then I have the e to the 5th power. Now I have 2 times x equals e to the 5th, which is just some number. So to get rid of the 2, I divide both sides by 2. So my answer is e to the 5th divided by 2. Or you may see it written as 1/2 e to the 5th. Those are the same thing. If you wanted to get the decimal approximation, you would just type it into your calculator and get out 74.207 if I'm going to round up. So here's my next example. Log x plus log 3x minus 13 equals 1. Now I can't go straight to the inverse operation because on the left I have 2 logs. So first I need to condense those. I need to shrink them down to 1, and then I can go to the inverse operation. You'll see my note off to the right. I don't see a base, so I'm assuming that it's a base 10. Now you don't necessarily have to write it in there, but assuming it's base 10. So I'm going to write this as log. Now I have log x plus log 3x minus 13. So I see that addition sign, which is going to turn to multiplication. That's my product rule. It just looks a little different. So that is my condensed log. So I used my properties to combine those to multiplication. Now that I have one log, remember it's base 10. To undo that, it's log base 10, so I'm going to 10 to the power of that thing on both sides. The log and the 10 will cancel, which will leave me with x times 3x minus 13, and 10 to the 1 power, which just equals 10. So however you want to write that, 10 to the 1 is 10. So I'm going to distribute that and have 3x squared minus 13x equals 10. Move everything over to the left, factor it. So I factored it to 3x plus 2x minus 5. Zero product property says set each piece equal to 0. Solve those both down and I get x equals 5 and x equals negative 2 over 3. But if you remember with logs, can't have a negative number inside the log. So here, inside where there's an x, and then there's an x, but log x. So I throw out the negative 2 over 3, meaning my final answer is x equals 5. Last one, a whole bunch of logs. All you're going to do is go through and condense everything down. So on the left, I'm going to condense this thing, make it 1 log, and since they have the same base, I'm good. So I have log 7. That is subtraction, so it's going to turn into division. I have 4x over x plus 3, and then equals log 7 of x. Now I'm going to, because it's base 7, I'm going to 7 both sides, which will make both of those cancel out. And then I will have 4x over x plus 3 equals x. Now you can think about this as x over 1 and cross multiply, or you can multiply both sides by the denominator, x plus 3. It doesn't matter. I'm going to multiply both sides by x plus 3 because it's divide by, so to undo division I would multiply, which will give me 4x on the left, and then x times x plus 3. Going to distribute the x, and then I need to get all the x's on one side. So I'm going to minus 4x, which will then give me x squared minus x equals 0. So I went ahead and flipped the order as well. Factor out an x, which will give me x equals 0 and x equals 1 coming from my x minus 1 solution. So think back with me to the graph. This is the graph of log 7 of x. Now we've talked about how you can't have negative numbers inside because there's no graph over here at the negative x's. But also, if you remember, you can't have 0 inside of a log either because the graph never actually gets there. It approaches it, but it never actually reaches it. So if I were to plug in 0 right here, I would get log 7 of 4 times 0, which would give me log 7 of 0. And if you type that into your calculator, it'll tell you a domain error. You can't have 0, so your final answer is just x equals 1 or the solution set 1.